let's look at section 10.2. We've already talked about in section 10.1 how to set up our hypotheses. Okay, so now in section 10.2 we want to be able to go through and actually do the hypothesis test. Okay, one important thing here, let me resize this here. Okay, one important thing here is that in this section in 10.2, the way we're going to go about things is under this assumption that we know the population standard deviation. Okay, lots of times that is not the case, but that's what we'll talk about in 10.3, what to do when we don't know it. So here we are making that assumption. And then one other important thing in this section, the way that we draw our conclusion at the end of the test is that we're going to use this thing called a p-value. Okay. I'll use this thing called a p-value to make our conclusion. Okay, so the general steps, the way a hypothesis test goes, is that we start off with our hypotheses. That's what we talked about last time. Then we figure out what formula we should use for our test statistic. We're only going to have one to deal with right now in this section. And we state our level of significance. Remember, that's the area in the tails, alpha. Then we gather our data. That's for us, we're just going to get our data from the problem and then calculate our sample statistic or our test statistic. And then we will draw our conclusion. Okay. In this video, the main thing I want to talk about is this idea of how we come up with a p-value. We'll look at the formula for a test statistic, but we're going to focus on this p-value idea, and then I'll do another video working some examples. Okay, so let's briefly look at our formula for a test statistic. Okay. So in the situation where we know the population standard deviation, then we would use this formula. Something else we need is we also need the central limit theorem to be in effect, okay, because we need to know the shape of that sampling distribution of sample means. Okay, so we need to know a symmetric and bell shape. So if we know sigma, and if we have a sample size of at least 30, or know our population data is approximately normal, approximately symmetric and bell shape, then we can use this formula for a test statistic. Okay, in this case, we're going to get a z test statistic. Okay, so we'll be using the normal distribution. If you look at the formula on the top, we've got x bar minus mu. Okay, x bar is the sample mean, mu is population mean, so that can be a little confusing because we've got two means in this formula. And then in the bottom, we're dividing by the population standard deviation over the square root of the sample size n. Okay, so something that's really important to remember here, okay, is that this x bar, okay, this value here is always going to come, let me rearrange my screen here a little bit, it's always going to come from our sample data. Okay, so when it says we've collected some data and calculated the mean, that's going to be x bar. Okay, but this mean mu, okay, is always going to come from the null hypothesis. Okay, so this is the value that we're starting out assuming to be true. Okay, so whatever value we have for mu in our null hypothesis, that number is going to go right there in that mu spot in the formula. Okay, and then sigma is our population standard deviation, and n is our sample size. Okay, and we'll come back and use this formula in the next video. I just wanted to talk about it to give you a little bit of help here, and we'll work some examples using it in the next video. Okay. The main thing I want to focus on in this video is coming up with this thing called a p-value. Okay? But before we can talk about p-values, we need to talk about the fact that when we're doing a hypothesis test, okay, there are three versions. Okay, we say there are three types of hypothesis tests we can do. We can do a right-tailed test, a left-tailed test, or a two-tailed test. Okay? And the way we figure out which one we're doing, which setup we have, is by looking at the alternative hypothesis. Okay, HA, the alternative hypothesis. Once we have the hypotheses picked out, the alternative hypothesis is where all the action happens. Okay, that's pretty much the one that we're going to be focused on. And the idea here, it's really easy to figure out which type of test we're doing, because if our alternative hypothesis, it only has three symbols that we can have. So if it has a less than symbol, that means we're going to be doing a left-tailed test. And the way we can remember that is if we make an arrow out of less than, it points to the left, so this is a left-tailed test. If we have a greater than symbol in our alternative hypothesis, greater than, if we make an arrow out of that, it points to the right, so that's a right-tailed test. Okay. And then if we have the oddball symbol, if we have the not equal to symbol, then that means we're doing a two-tailed test. Okay, so what type of test we're doing, if it's left-tailed, right-tailed, or two-tailed, that's going to be really important for a lot of the steps coming up in our hypothesis testing procedure. So you really want to make sure less than points to the left, that's a left-tailed test. Greater than points to the right, that's a right-tailed test. Not equal to, that's going to be a two-tailed test. So it's really important that you can figure out if we're doing a left-tailed, right-tailed, or two-tailed test. Okay. So now let's talk about a p-value. Okay. Our definition says a p-value is the probability of obtaining a sample statistic as extreme or more extreme than the one observed in the data, assuming that the null hypothesis is true. Okay. So the idea here is that we start off assuming the null hypothesis is true, and then we look to see where our test statistic from our data is. Okay, so like if our test statistic was somewhere over here in our sampling distribution, then we would say, well, that's not very likely we would get that test statistic if our null hypothesis is true. So that would be a small p-value. Okay, I would say that's pretty unlikely. If we had a test statistic that fell somewhere right in the middle, well, that's what we expect. So that would mean we'd have a really high chance of the null hypothesis or getting that sample test statistic if the null hypothesis was true. Okay, so a smaller p-value is going to be off in the tail somewhere, okay? And then a larger p-value would be more toward the middle. And what we need to do is we need to be able to put a number, to actually come up with the number for our p-value given a test statistic. Okay, so to come up with a p-value, we need two things. We need to know what type of test we're doing, left-tailed, right-tailed, or two-tailed. We get that from the alternative hypothesis, and then we also need a test statistic. Okay, so let's look at a couple of examples here. You actually already know how to calculate these. We just haven't called it this yet. Okay? So this says calculate the p-value, assume the data have been collected, and the test statistic was calculated to be negative 1.34. Okay, so this one just gives us the test statistic. That number would have come from that formula we saw a minute ago. Okay, and then this would be what we got out of our calculator is negative 1.34. That's our test statistic from our sample data. So now we've got our test statistic, so the other thing we need to know is this a left-tailed, right-tailed, or two-tailed test? So what we do is we look in the alternative hypothesis. We have a less than symbol in the alternative hypothesis, so this is a left-tailed test. Okay. So since this is a left-tailed test, we want the area to the left of our test statistic. And the area to the left of that test statistic is going to be our p-value. So left-tailed test, we want the area to the left of the test statistic. Okay, so what we would do, we would go to our tables, we would look up the area to the left of negative 1.34. If we're using the tables we've been using, we just look up negative 1.34 in the table. If we do that, if we look up negative 1.34, we get the area to the left of that test statistic, 0.0901, and that is our p-value for this test statistic, the p-value for this hypothesis test. Okay, just the area to the left because it was a left-tailed test. Okay, let's look at another one. Okay, same idea, we want to calculate the p-value. This one ahead of time has calculated the test statistic for us, so our test statistic here is 2.78. Now we need to figure out what type of hypothesis test we're doing. So we look at the symbol in the alternative hypothesis. This points to the right. So this is a right-tailed test. Okay. And so since this is a right-tailed test, that means we want the area to the right of our test statistic, 2.78. Okay. So using our tables, one way we could do that one is we could look up the opposite, right? Area to the right means opposite, so we could look up negative 2.78 in our table. When we do that, if we look up negative 2.78, we get an area of 0.0027. So we have an area of 0.0027 to the right of our test statistic 2.78, and that is our p-value in this case. Okay. So we've done the left-tailed, we've done the right-tailed. Let's do one more. We got one more coming, right? Let's look at this one. It says calculate the p-value. Our test statistic is negative 2.15. Okay, so then we need to figure out what type of test we're doing, left-tailed, right-tailed, or two-tailed. In this case, our symbol is a not equal to symbol, so this is going to be two-tailed. Okay. So the two-tailed case is the one where we have to think just a little bit harder, okay? Because we don't just want the area to the left of some number or the area to the right of some number. What we're looking for here is if we have our curve, our test statistic is negative 2.15, so that's over here. And the opposite of that is 2.15. Okay, so in this case, we're thinking about both of these values. And the area we want is we want the area to the left of the negative one and the area to the right of the positive one. Okay, but remember, these two z values are symmetric. So one thing we can do is we can find this area. The left tail is a little bit easier for us to find, so you can look up the negative version of the test statistic. And then we're going to do 2 times this area. That will be our p-value. So if we have a two-tailed test, you find the area in one of the tails and multiply by 2. So in this case, what we could do is we could look up negative 2.15. Okay. If we look up negative 2.15, that has an area of 0.0158 to its left. Okay. And we could do 2 times that to get our p-value. That's only half of our p-value, so we need to do 2 times that value. Okay, so we could do 2 times 0.0158. Okay, what do we get there? 0.0316. So our p-value here would be 0.0316. Okay, you can add the two p-values together, or you can multiply by 2 in the two-tailed case. Okay, so those are all 3 situations where we need to find the p-value: left-tailed test, right-tailed test, and a two-tailed test. So once we have the p-value, how do we use that to make our conclusion at the end of our hypothesis test? Remember, we have 2 possible conclusions. We either reject the null hypothesis or fail to reject the null hypothesis. Well, we do that by comparing this p-value we found with our alpha, our level of significance. Okay? And our rule says if our p-value is smaller than alpha, smaller than our significance level, then we reject the null hypothesis. Okay? So less than or equal to alpha. If our p-value is greater than alpha, then we fail to reject the null hypothesis. Okay? So a small p-value means that test statistic is really unlikely to happen if our null hypothesis is true. So we say that's pretty strong evidence in favor of the alternative hypothesis, so we reject the null hypothesis. Okay. If our p-value is bigger than alpha, then we're saying, well, that test statistic is what we expect if the null hypothesis is true, so we don't have any evidence to reject the null hypothesis. In that case, we fail to reject the null hypothesis. Okay? And these can be a little tricky to remember, so forgive me ahead of time for this, but one way you can remember which one's which when you reject the null hypothesis is if the p-value is low, or in other words, if the p-value is smaller than alpha, then reject the null hypothesis, okay? Kind of funny, but it'll help you remember. So if the p-value is low, if our p-value is smaller than alpha, then reject the null hypothesis, okay? That'll help it stick with you, okay? So let's practice a little. We've got two situations here, and we want to figure out what our conclusion to our hypothesis test would be. So we're saying we've got a hypothesis test set up. We've already calculated our p-value is 0.0146, and then we've got two different scenarios here. So part A says that the stated level of significance is 0.05. What's the conclusion to the hypothesis test? So this 0.05, this level of significance, that is our alpha. Okay. And just to keep things from being confusing, it might be a good idea to always write the p-value on the same side. So for me, I usually always write my p-value on the left side. So my p-value is 0.146. My alpha, my significance level, is 0.05. So what's our relationship here? Well, 0.0146 is smaller than, it's less than 0.05. So here our p-value is smaller than alpha. Our p-value is low. So what's our conclusion? We would reject the null hypothesis in that case. Okay, so if our p-value is small enough, how small? Smaller than alpha, then we reject the null hypothesis. Okay, what about this other one? It's giving us a little bit of curve. It's not giving us significance, it's giving us confidence. Okay, so it says if the confidence level is 99%, what would the conclusion be here? We're using the same p-value, but it gives us confidence instead of significance. Now remember, confidence is the area in the middle of the curve. Significance is the area in the tails. So to figure out our alpha, we do 1 minus the confidence, 0.99. So our alpha here is 0.01. Okay. And then we got to make our comparison. So same p-value, 0.0146. But this time our alpha is 0.01. So what's our relationship? Well, 0.0146 is bigger than 0.01. So our p-value is greater than our alpha. Our p-value is not low, it's big. So we fail to reject the null hypothesis. Okay. Those are the two situations we can have. Okay, so on that one we fail. Okay, next video I'll try to have it up tomorrow. We'll work all the way through some examples here, and then I'll be working on the video for section 10.3. Section 10.3 is really similar to this section. Really the only big difference is that we're using a different method. We're not using p-values. We're using something called rejection regions to make our conclusion at the end. So if you get this section down, section 10.3 is pretty easy. Okay.